All right, folks, it's Bass Action, back in action here. In this video, we are going to cover surface area and volume of spheres. And then at the bottom of the page, we're going to do another composite figure, similar to the last video, but now we're going to incorporate the spheres. Okay, I'm going to jump straight into this first example here, and I'm just going to give you the formulas, and I have some activities that we'll do in class to help you discover and understand why these formulas make sense. This first figure that we're going to look at is a complete sphere, and you will often hear me refer to this as a ball, okay? So it's a whole ball, the whole sphere. And the formula for the surface area of a sphere or a ball is 4 pi r squared, okay? Now, this formula is because we're going to look at what's called this great circle here. And the radius is going to be the radius of this great circle. And the great circle is the largest circle that can be drawn in the sphere that would also have the center of the sphere as the center of that circle. Okay, so we're going to have our great circle here, and it could, of course, be drawn in a variety of ways to get that surface area. I do also want to point out that spheres do not have lateral areas. They just have surface area. So we're just going to talk about the area of the sphere, and there will not ever be a lateral area question. So to find the surface area, we're just going to jump straight into this formula. You can see I already gave you the radius. So our surface area is going to be 4 pi, and then we'll do our 24 squared, which will give us a pretty big number of 2,304 pi meters squared. Okay, now our volume, the formula for our volume for a sphere in the whole ball is going to be 4/3 pi r cubed. And it makes sense that it should be an r cubed because volume is also units cubed. Now, you're going to need to make sure that you're keeping track of your fractions here when you're working on our volume. Be pretty careful. So we'll have our 4/3, and this one's going to be pretty simple, our pi, and then our radius cubed is going to be, it's a pretty big number, 13,824. Now, I know I can feel good that this is going to be divisible by 3 because I got this number by cubing 24. That's, of course, divisible by 3. So this 3 is going to cancel. That's going to cancel. I'm going to get 4,608. So my complete volume for the entire sphere is 18,432. Now be really careful. It's easy to forget the pi and then meters cubed. Okay, so we've just got a really good basic one here. Remember, this is what I'm going to call a ball. Our next problem is what I am going to call a bowl, okay? So this is like a bowl. And our bowls will always have a lid, okay, with it, a bowl with a lid. And what that's saying is we're going to have a half sphere here, okay? So if we were thinking surface area, this outside piece would be half of this. So this is going to be 2 of our pi r squared. But it also is going to have this lid, okay? We're going to imagine kind of a lid on a bowl of cookies. So we're going to have a lid right here, and that's going to add another pi r squared. So our surface area for this bowl is going to be 3 pi r squared. And after that, we're going to jump into our formula. So we'll have our 3 pi, and our radius squared in this case is 81. We could just do that in our head. So our surface area is going to be 243 pi inches squared. Now, the volume, what we need to think about is for our volume is we're trying to do half of the sphere. So we're going to do 1/2, and then our 4/3, and our pi, and our radius cubed. Now, of course, we can immediately clean this up. This 2 is going to cancel with that 4, and we'll get a 2 there. So if you want to memorize the separate formula, you can, but I don't generally recommend it. So we're going to have 2/3 and our pi, and our radius cubed is going to be 729. And of course, this is going to cancel. The 3 will go into the 729 243 times. So our volume is going to be 486 pi inches cubed. Okay? So there's two really basic ones, our ball and our bowl. Now let's take a look at what we would do with maybe some more complicated numbers, and then also what we would do if we were trying to work backwards. So on example 3, we're going to work backwards. We're going to have the surface area. We're going to be given a surface area, but we ultimately want to find volume. So now we need to work backwards. We're going to have our 5,184 pi. It was an entire sphere, so we can set that equal to 4 pi r squared. Of course, the pi's are going to cancel. Then we can divide by 4, so we're going to get 1,296 equals r squared. And if you quick poke that in your calculator, you're going to find that is in fact a perfect square. So the radius of our sphere was 36. So now we can just go right back into the formula. So our volume is 4/3 pi. Notice that I'm keeping all of my fractions nicely aligned. It helps me figure out a little more easily what's going to cancel. Now, 36 cubed is going to be really big. We're going to have 46,656 over 1. And then we will cancel our fractions. They're not always going to turn out so nice, so you do want to get in the habit of keeping track. So 15,552, that's going to reduce. And our final volume is 62,208, don't lose the pi, meters cubed. Okay, so that's our final answer there. Now, the next one that we're going to look at is going to be the surface area and the volume of a hemisphere. And when we talk about a hemisphere, we're talking again about that bowl, okay? So if we want the surface area, remember our surface area for the hemisphere is going to be the bowl and the lid, so it's going to be 3 pi r squared. So our surface area is going to be 3 pi. And look at this radius. It's an interesting radius for us. We can square that radius. The square root of 5 squared is going to then be 5. So our surface area is going to be 15 pi inches squared. Now, it's the volume that's going to get especially interesting for us here. Okay, so on our volume, it's a hemisphere again. So we're going to have our 1/2, our 4/3, our pi, and our r cubed. Now we need to cube that radical without having to convert this to a decimal. So that means that I'm going to do a radical 5 times a radical 5 times a radical 5. These are going to give us a 5. So when I plug this in, oh, and I'm going to go ahead and I'm going to reduce that right there. So my volume is going to be 2/3 pi, and then the radius cubed becomes 5 radical 5. So my final volume answer, it's going to look very, very strange. I'm going to multiply the 5 and the 2. That's going to give me my 10. I'm still going to have the pi, I'm still going to have the radical 5, and I'm going to put the whole thing over 3. You do not want to convert any of this to decimals. Inches cubed. Okay? All right, the last thing that I want us to take a look at quickly, I know this video is a little longer, is that we are going to look at a composite figure, and this is going to let us look at our last version of a sphere, and that's going to be what I'm going to call a bubble. Okay, bubbles will always be attached to something else. So if you see the half sphere kind of floating on its own, it's a bowl. But if it's attached to something else, like this cone, then we're going to call it a bubble. That means that the surface area for this is going to be a bubble I'll talk about its formula in just a second, plus the lateral area of the cone. So the bubble is only going to be half the sphere. We don't have to worry about a lid, so it'll be 2 pi r squared. Lateral area of our cone, recall, is 1/2 perimeter times slant. So that's going to be pretty easy. 2 pi, our radius is 2. So that is going to be a 4. So this is going to give me an 8 pi here. Then for my cone, I'm going to have 1/2. The perimeter is going to be 4 pi. My slant I'm already given is 5. That's going to give me a 10 pi. So my total surface area is 18 pi centimeters squared. For volume, I can just add those together. So the volume is not going to be as difficult, but our answer is going to look really, really gross on this one. So I'm going to do half the sphere. So that's going to give me a 1/2, my 4/3, my pi, and my radius cubed. I'm going to cancel, remind myself that's a 2/3 there. So I have 2/3 pi. My radius cubed is going to be 8. So notice that this is not going to reduce for me. This is going to give me a 16 pi over 3. Okay. Now I also need to find the volume for the cone, and in order to do that, I'm going to need this height. I'm going to do a quick Pythagorean theorem on that. That's going to give me a 25 and a 4 and my, meant to write an h there, my h squared. So my height is going to be the square root of 21. So now, for my cone, I'm going to do 1/3 my base times my height. So I'm going to have 1/3. The area of my base is 4 pi. My height is the square root of 21. Now when I pull this all together, that's going to give me 4 pi radical 21 all over 3. And since I do already have nice common denominators here, I can write this as one single expression of 16 pi plus 4 pi radical 21 all over 3 centimeters cubed. Okay? So, a lot of stuff going on there. You can also see there's a different variety of, instead of writing out complete lists, how you can keep track of your pieces and parts that you're adding together for the composite figures. So spend some time thinking about the bubble, the ball, and the bowl, and how to recognize the difference between those as well.